Chapter 7, Section 7, Solving Radical Equations. I believe this is our last section in this chapter on radical equations and expressions. We're going to solve equations because I'm trying to find the value for x that makes this a true statement. There's hopefully, ideally, some number for x that makes the statement true, and I want to find what it is. Notice that we have equations here and not expressions, so we can actually solve. I'm going to solve this just like regular. I'm going to do some sad mapping where I just try and get the x by itself. When I'm all done with this, I check for an extraneous solution, which means I check to see if the solution I got actually works. Because sometimes you can get equations here that don't actually work. So I'm going to try and get this x by itself. I start by subtracting the 9, and that gives me negative 1 equals negative 1/2 times the square root of 3x plus 1. I'm going to multiply both sides by negative 2. I wrote that parenthesis in a weird spot there, but I get 2 equals the square root of 3x plus 1. Now to undo the square root, I can't try and subtract that 1, I can't try and divide by 3, I have to get rid of the square root first. To undo the square root, I square both sides. That gives me 4 equals 3x plus 1. Then I just solve, subtract a 1 from both sides, divide both sides by 3, and I get that x equals 1. I have to go back and check that to make sure that works. So I'm just going to plug a 1 in here for extra quick mentally and see what happens. So I do 3 times 1, 3 times 1 is 3, 3 plus 1 is 4, the square root of 4 is 2, 1/2 times 2 is 1, 9 minus 1 is 8, so I get that 8 equals 8, and it checks. You can check those mentally really quick, but you could also just plug it into your calculator and do 9 minus 0.5 or 1/2 times the square root of 3 times 1 plus 1. Make sure that looks okay. Should get out 8. I get out 8, so this answer checks. I'm good to go. Whenever you have just one radical, you just kind of solve like regular. Now this one on the right isn't a square root, it's a cube root, but I'm still just going to solve like regular, try and get that root by itself. Remember, right now, this still has a negative out in front. When I subtracted the 4, I didn't get rid of that negative. So if I divide both sides by negative 1, or multiply both sides by negative 1, same thing in this case, move that negative over there. Now I find the cube root of negative 3. I don't actually know what that is, but that's okay. I'm sorry, I don't find a cube root, I cube everything. To get rid of this cube root, I cube everything. The inverse of a cube root is a cube. That's going to give me that x plus 6 equals negative 27, because negative 3 times negative 3 times negative 3 is negative 27. So x equals negative 33. I want to check that to make sure that it works. So plug in negative 33. Negative 33 plus 6 is negative 27. The third root of that is negative 3. 4 minus negative 3 equals 7, so it checks. That one's good. Whenever there's just one radical, you won't get extraneous solutions. You can get no solutions, that's certainly possible, or imaginary solutions, but you can't ever get no solution or get extraneous ones. Two radicals are the ones where things can get a little bit dicey. Right now I have a radical on both sides. Well, to undo a square root, I square, whatever I do to one side, I do to the other, so I can square both sides. And when I square both sides, the square roots just die, so I get that x plus 5 equals negative 2x plus 1, and this just becomes a linear equation that I solve. And I get that 3x equals negative 4, so x equals negative 4/3. Now I want to check to see if that works. This is much tougher to check in my head, so I'll do this in my calculator. Do the square root of 4 divided by 3 plus 5, negative 4 divided by 3 plus 5. Let's see what that equals. And I do the square root of negative 2 times 4/3 plus 5. They come out to not the same. Oh, it's plus 1, not plus 5, excuse me. I go back and change this plus 5 to plus 1. Negative 2 times 4/3 plus 1, that should be a negative 4/3. Sorry, I'm kind of a mess. Negative 2 times negative 4/3 plus 1. Yes, that was the same thing as the thing that I had before. this one did the same thing, so this one works. Sorry that check. When there's two radicals on the same side of the equation, these problems are actually much, much simpler if they're on opposite sides of the equation. You want these radicals on opposite sides, so I'm going to add a root x to both sides. I get the square root of x plus 3 equals 1 plus the square root of x. Now, just like we did last time, I'm going to square both sides. But this has a binomial on the right side. This has two terms. We haven't seen a binomial that we're squaring yet today. So when I square that, it actually has to FOIL. When I do the first, outer, inner, last. I kind of hate the term FOIL, but I know that we all use it, so I'm going to stick with it. We FOIL this. And I get x plus 3 on the left side, that's no problem. But on the right side, I have to work out 1 plus the square root of x times itself, 1 plus the square root of x. So it's x plus 3 equals 1 times 1 is 1, 1 times root x is root x. Root x times 1 is root x. The square root of x times the square root of x is just x. So now I have x plus 3, and I simplify the right side, 1 plus 2 root x, because root x plus root x is 2 root x. Just add the coefficients like there's 1s in front of these, plus x. And I have a radical still. I have this 2 root x term left over. I still have to deal with that radical. So I'm going to move everything away from it. Subtract a 1 from both sides, subtract an x from both sides, and I end up with 2 equals 2 root x. Divide both sides by 2. 1 equals root x. Square both sides, and I get that 1 equals x. I'm going to check to see if that works. I plug a 1 in for x. Square root of 1 plus 3 minus the square root of 1. That's going to be the square root of 4 minus the square root of 1. Square root of 4 is 2, square root of 1 is 1. It's supposed to come out to a 1, which it does. So this solution is good. Now these are both scenarios where extraneous solutions are possible. Whenever there's two radicals, it's very, very, very possible to have extraneous solutions, so you should always check. The next one I think is the one that will have extraneous. Yeah, this one's going to have extraneous. Oh, that's my phone. Give me 1 second. Okay, I'm back. That was my wife, in case you were curious. We're going to solve this one. Again, I want to get the radicals on both sides. I think I'm going to move this one. I'm going to get this in a smaller font. I'm going to move the one on the left just because it's a smaller term. It's a monomial, not a binomial. But I want to have radicals on opposite sides. I'll try and show why in a second why you want that. So now I have the square root of x plus 2 equals 4 minus the square root of 2x. And again, square both sides. I have to square the whole sides entirely. I can't square just parts of the expressions or with square things I want to square. I have to square the whole sides entirely. On the left side, I just get x plus 2. On the right side, I have to FOIL 4 minus root 2x times 4 minus root 2x. So I have x plus 2 equals 16. 4 times 4 is 16. 4 times negative root 2x is negative 4 root 2x. Negative root 2x times 4 is negative 4 root 2x. And then root 2x times root 2x is just plain old 2x. That looks pretty messy, and I apologize for that, but you can hopefully find your way through it. Simplify the right side, so it becomes 16 minus 8 root 2x plus 2x, because these two terms here can combine. I want to get this radical by itself. I'm going to try and get that by itself now, so I subtract 16 from both sides. Subtract 16 here, and subtract a 2x from both sides. And I get that negative x minus 14 equals negative 8 root 2x. Let's make this 3. Okay, this is kind of getting dirty, but we're going to live with it. At this point, I could divide both sides by negative 8 if I wanted to. And I will show that. I can also leave the negative 8 over there. It doesn't actually matter. Why would you do that, Grant? I'll divide both sides by -8. I'm not going to simplify it all. I'm just going to leave that as a fraction. It's kind of a messy fraction, but it's -x minus 14 over -8 equals the square root of 2x. And from here, I'll square both sides to get rid of this square root. So square this, and square this. And this is why I didn't bother simplifying. It's all going to come out changed anyways. This is going to become +64 on the bottom, positive 64. And the top has to FOIL, so it becomes x squared plus 28x plus whatever 14 squared is. And that equals 2x. I'm going to multiply both sides by 64. Get rid of this fraction. This is why dividing by 8 wasn't really necessary all along. We have x squared plus 28x. I'm going to calculate what 14 squared is now. 296? I think it's 296. I should know this. I'm kind of embarrassed right now. 196. Duh. Come on, Grant. Idiot. Okay, this is a quadratic. This right here is a quadratic, which means we have to solve it by factoring or by quadratic formula or by completing the square or however you want to solve it. But the first thing I want to do is get it equal to 0. So I have x squared minus 100x plus 196 equals 0. I'm going to solve this by doing the quadratic formula. Keep pressing the wrong one there. So I'm going to do in parentheses negative b, which is 100, plus the square root of 100 squared minus 4 times 1 times 196. Close my parentheses. I press divided by when I wanted times. I'm going to divide that by 2 times a. One of my answers is 98. Okay, and find the other one. Changes plus to a minus. And the answer is 2. One of these doesn't work. So I have to go all the way back to the original problem, plug in those 2 possibilities, and see which ones work. So I can do that in my calculator as well. Excuse me. I do the square root of 2 times 98 plus the square root of 98 plus 2. Do I get 4? I do not. So this one doesn't work. Let me check the other one. I do the square root of 2 times 2 plus the square root of 2 plus 2. Pretty sure I get out 4. And I do. And this is the one that works. Beautiful. That problem, in my opinion, is as bad as it gets in this class. All about IITrig. I think we'll see one other chapter that has problems kind of as tough as this one, but I don't think it get any worse than this. So if you feel you can handle this, then you're in good shape. And I get that this takes a lot of work, and it involves everything we've done, so you have to simplify and solve and deal with radicals, and then deal with quadratics, and then check things, and there's a lot happening, but it's definitely a worthwhile problem, and a problem you should be able to handle. It's a problem that might take some work, but you should get to the point you can do these. Here's the last one that we'll do. It should be kind of simple compared to the last one. Instead of having radicals, sometimes you have powers. I mean, this is the same, this to the 1/3 power is the same as having a 3x minus 2 plus 8 equals 13. This is the same thing as having a third root. So you have this 1/3 power. To solve it, I can just solve this equation like regular, where I subtract an 8 from both sides, and I get 3x minus 2 to the 1/3 equals 5. Now I really want this 1/3 right here to become a 1. I want to make that go to the first power, because that's the inverse of 1/3 is 1. Well, I guess the identity is 1, that's what I'm trying to say here. So what I'm going to do is take both of these expressions to the third power, just like I was killing a third root. If I take these to the third power, on the left side, the 3 and the third root just cancel. So I have 3x minus 2, 5 to the third is 125, so 3x equals 127, so x equals whatever 127 divided by 3 is. That's actually not going to be a whole number, so I'm just going to call it 127 over 3. Check to make sure that works. It totally works. If I want to solve this one, first thing I would do is take both sides to the 4/3. Because 3/4 times 4/3 is going to cause those things to cancel. So I'd have 2x plus 1 equals 8 to the 4/3. 8 to the 4/3, if you want to take a second and try and figure that out in your head, that is worthwhile. What is 8 to the 4/3? It's actually 16, because 8 to the 1/3 equals 2, and then 2 to the 4th equals 16. So 2x equals 15, x equals 15 over 2. This won't have an extraneous solution, so we're good. Okay, that's everything. Thank y'all.